Okay, so 1.5 here. This is actually going to be our last lesson. We're actually going to push the 1.6 lesson. We can put that in a different unit, so we're choosing to do that. So this is our last lesson to wrap up all of our introductory stuff. So we got some new vocab here, and I want you guys to add a couple things. You should have already done the quiz, the scavenger hunt quiz, which I'm kind of modifying for this. But in the scavenger hunt quiz, it only talked about a couple things. Talked about the definition and being able to identify vertical angles and a linear pair, complementary and supplementary. What I want you to add onto your notes here, please, is that vertical angles are congruent. So please write that in your notes. Vertical angles are congruent. And again, congruent is just a geometry term that means the exact same thing as equal when those angles are across from each other. So again, vertical angles are across from each other. So these two are vertical angles and these two are vertical angles. When we're looking directly across from each other just like that through the cross, we call them vertical angles. A linear pair now, these are not equal. If you notice a linear pair, these two things together, here is 6, here is 5. A linear pair, together, they add up to be a straight line, right? If you notice, this opens up here, this opens up here. Linear pair adds up to how many degrees are in a straight line? 180 degrees, actually. That's, again, something we'll have to memorize here. 180 degrees happens to be a half circle, which is why sometimes you'll see that marked with a little half circle there, right? 360 is a full turn, 180 is a half of a turn. So that's really important things you need to add. Vertical angles are equal, linear pairs add up to 180. Now we also call adding up to 180 supplementary. So again, that picture right there, adding up to 180 is the definition of supplementary. Adding up to 90 is the definition of complementary. Let's go ahead and let's practice a bit with identifying these things. So we have this kind of complicated picture here. We've got some things that cross. When we have lines that cross like this, we've got these relationships, possibly some linear pairs, possible vertical angles, but we've got this line here that kind of throws us off. So all we're doing to start off by now is just saying, is this true? Are they a linear pair? Are they vertical angles? So let's look at angles 1 and 2. We want to see if they're a linear pair. So what we're looking at is if I draw them together, will they create a straight line together? So here's how you want to kind of figure this out. Here's angle 1, and then angle 2 keeps going. Notice together, they open up to create a straight line. So the answer here is yes, which means they add to 180, right? A linear pair, those two angles together would add up to equal 180. So let's try the next one, 4 and 5. So same thing, I'm going to trace 4, I'm going to trace 5, and I'm going to see if I can create that half circle for my straight line. So here's 4 and 5. Do those two angles together give us a full half circle for our straight line? No, they don't actually, yeah. It doesn't open all the way. If I included the 1 in there, then yeah, that gives me my full half circle, which is for a straight line, a straight angle. But yeah, those two together are not a linear pair because they don't create a straight line. Let's look at 5 and 3 now. So 5 and 3. So I'm going to mark 5. I'm going to mark 3. Here's 5 and 3. Well, they're not even touching. Yeah? To be a linear pair, they have to be touching. And we have this gap right here, yeah? That doesn't work. We need that full rainbow whoop to give us a linear pair. And yeah, no, they are not a linear pair. They're not even touching. Let's look at 1 and 3 now. So vertical angles now is what I'm checking for. So vertical angles mean when I'm in a cross, they are opposite each other in that cross. So here's 1 and here's 3. What you need to notice is 1 and 3 are across from each other. They're on opposite sides of that X, right? One straight line, they're on opposite sides of that X. We would call these vertical angles. Vertical angles are once again opposite each other when we have an X. So these would also be vertical angles, yeah. Now I need to say here, though, that 5 and 2, or 4 and 2, are not vertical angles because of this funky line going down right here. It's only one x that we're looking at when we're talking about vertical angles and linear pairs. This line kind of throws stuff off for, again, dealing with 2. 2 and 4, 2 and 5, those aren't vertical angles. But because 1 and 3 are vertical angles, again, we just wrote down that vertical angles are equal. They're going to have the exact same measure. Basically, it's because they're like mirrored versions of each other. Yeah, they're across from each other in that x. They are going to be equal. The linear pair, that full rainbow, adds to 180. Across from each other, they are equal. Let's try some more time in this picture. We're looking for 2 and 3. So I want you to mark 2, mark 3. See if we make a perfect half circle. If we do, we say yes, they add to 180. If not, then they're not a linear pair. So mark 2 and 3 and see what you get. Well, here's 2, here's 3. That's more than a perfect circle. See how this kind of goes wonk, and then veers off? This needs to be a straight line like that for 2 and 3 to be a linear pair. So they're not a linear pair there. Together, they actually would open up to be more than 180. Again, 180 is a half circle, and they're like, can't bend my hands that way, going a little bit too far. Let's check 3 and 4. So same thing, I want you to mark 3 and 4 and see if we make a perfect half circle when we connect them. Well, here's 3 and 4. They do make that straight line, right? Together, they open up to that straight line. So this is yes, actually. Together, they make a perfect straight line, which again means they would add to be how many degrees? 180 degrees. So whatever 4 was, whatever 3 was, they would add together to give us 180. Now let's check 1 and 3 here. Now 1 and 3 we want to be verticals. So mark, see where 1 and 3 are at. What we need to have vertical angles is 2 perfectly straight lines. The same 2 lines create the angles. So let's look at 1 and 3. Here's 1, here's 3. Well, they look like they could be vertical because I kind of have an x and they're across from each other. The issue is kind of the same thing I was dealing with before. 1 and 3 are not made by the same 2 lines. This is a broken line. I would not call this and this here part of the same line. A line is straight, and that's broken. So no, 1 and 3 are not vertical angles, even though it looks like it. If this line continued up this way, instead of veering off right here, then yeah, 1 and 3 would be vertical. But nope, with it veering off like this, they're not vertical angles. So as you can guess, probably, same thing is going to happen for 2 and 4. Yes, it looks like they're across from each other in the x, but this is not an x. It's like I broke my arm and went, yeah, just like that. It's got to be a perfectly straight x, and this is not to have vertical angles. So we're going to pause there. That's really the basics of it. We're going to continue to work with this, as always, on Tuesday when we come back, and we'll start adding in the equations and all the fun stuff from there.